In question 6, we start with exponential functions. Let's have a brief look at exponential functions. So with exponential functions, they look like ramps. So they can exist above the asymptote if a is positive and below the asymptote if a is negative. And we've got one asymptote for exponential functions, which is located at the end here, and it is a horizontal asymptote that goes from side to side. Now with our particular equation, do you see how they're not adding anything at the end? So if they're not adding anything at the end, we assume like they're adding 0. So now we know where our asymptote is. And we can color code our graph accordingly. So we have an exponential function. So you can see here, check out the shape of this exponential function. It's adopting this shape here. So I already know my a value is going to be positive and my base is going to be smaller than 1 but bigger than 0 at the same time. So if we need to write down the domain of f, this graph goes on forever with the x values. It goes forever to the left and forever to the right, so it exists at all x values. And we can represent that in one of two ways. I can say x is an element of real numbers, or I can say x is an element that spans from negative infinity to positive infinity, always using circular brackets for infinities. And if I have to write down the equation of the asymptote of f, it's here. It's this y equals 0. It's this dashed line that goes across that is on top of the x-axis. And your 2 marks simply just come from the answers here. In 6.3, we are given the b value. It's 3 over 4. And with that, we need to calculate the value of a. So we're going to go ahead and replace this b with the value they supplied to us. And then to get missing stuff in my equation, I need to sub in a point. So I'm going to sub this point into this graph. And we do it just like this. F of x is a fancy placeholder for the y value. The y value is 144, so I pop that in there. And then this x, I simply just change it to this x value of 2. And now I can work out a. So I'm going to square this bracket quickly. And when you square it in your calculator, just make sure to wrap it in some brackets. And then you see you get that 9 over 16 that I've got over there. And now to get a on its own, we need to divide by the number in front of it. So we're going to divide both sides of the equation by this 9 over 16. And I must type it into my calculator like this. Just make sure you say 144 and then use the divide button and a fraction over here. Press equals. And then we get our a value to be 256. Now they're not actually asking you to get the a value. What they actually want you to do is take that a value, put it back in, and finalize your equation. And your 2 marks over here come from your substitution as well as your final answer for a. In 6.4, there's a new graph G that is obtained by reflecting f over the y-axis, and we need to write down the equation of G. So we're going to reflect the red graph over the y-axis and we will get this green graph G. And we're briefly going to go through this transformation. So the transformation is the reflection over the y-axis. The notation is when your x changes to a negative x. So if you see the negative inside the bracket in front of x, and the rule is to change x to negative x. So that's exactly what we do to get its equation. We just change this x to a negative x, and then it's g of x's equation. So we use the red graph because that's the one that's being reflected, and then it's as simple as that. Next up, we need to tell them if g is an increasing or decreasing function, and just remember g is your green graph. So going from left to right, you can see we're going uphill. If we're driving a car, we're going uphill. So it's definitely an increasing function, and if we had to give a reason, as your x value increases, your y value also increases. And your 1 mark in this question just comes from the correct equation for g of x, and your 2 marks in this question come from the word increasing as well as the correct explanation. In 6.6, we've got a bit of hieroglyphics over here, and yeah, we need to prove that this mess is equal to that mess. Okay, we're going to start with the left hand side. So with the left hand side, I'm going to keep the structure exactly the same. So this f of x, I'm going to replace it with f of x's equation inside the square bracket over here. And then you can see I'm still maintaining that square on the outside of the square brackets. Then I'll put that minus here. Now f of negative x, that's giving you instructions to replace this x with a negative x. So you can see I've done that inside over there. And now to simplify this, we're going to distribute those exponents in, aka shower the power. And we multiply exponents when we do that. So we're just going to get 256 to the power of 2, because if it doesn't have an exponent, you assume it's 1. And then 2 times x will give me that 2x. And then 1 times 2 will give me this 2 over here. And 2 times negative x will give me this negative 2x over here. And that's as far as you can simplify. So now we're going to direct our attention towards the right hand side. And then when I start with the right hand side, I want to keep the structure exactly the same. Now you see this a over here. We got a earlier to be 256. If you remember back to question 6.3, you can see here a is 256. And that's why I changed these a's to these 256's. Now this f of 2x, it's giving you instructions to take this equation, replace this x with a 2x and put it inside of here. So we do that. You can see here it's a 2x. And then for the next one, very similar. It's giving you instructions to replace this x with minus 2x. So we do exactly that. And then to simplify this mess over here, we are going to distribute the 256's inside. And when we do that, we add their exponents. So if I add their exponents, I just say 1 plus 1 to give me this 2 over here, and then this does not change at all. I'm just multiplying these factors over here. Likewise over here, I'm just going to multiply these two. This does not change at all. And I simply add the exponents there, and I get 256 squared, and then that fraction to the power of minus 2x. Now you can see this expression for the left-hand side is exactly the same as this expression for the right-hand side. So now we've officially proved that this mess is equal to this mess. And wrapping this question up, your 3 marks are awarded for the substitution in this line, the expression for the left-hand side, and the expression for the right-hand side.